Scope of declarations. Java has some basic scoping rules that you need to be aware of to properly construct your classes and understand where you have access to certain identifiers in your classes. So first of all, let's overview what those basic scope rules are. Then we'll take a look at an example, and for the purpose of the example, we're actually going to run it in a debugger so that we can see how the scope rules affect what we're allowed to access in our program. So the basic scope rules are as follows. When you declare a parameter for a method, the scope of that parameter is the entire body of the method in which it's declared. For a local variable, the scope of a local variable declaration is from the point where it is initially declared, which can be anywhere throughout a method definition, to the end of the block in which it is declared. If you happen to have a nested scope, for example, you might have an if-else statement, and within the if body you have a bunch of statements. If you were to declare a variable in the if body, the scope would just be the body of that if. The scope of a variable that's declared in the header of a for statement is the entire for statement, and the scope of a method or field that is a variable of your class is the entire body of that class. Now, in addition to that, we have a concept called shadowing, which occurs in the following scenario. If you have a field that is an instance variable or static variable of your class, and it has the same name as a local variable that you are using in a given scope, the local variable hides or shadows the instance or static variable for the duration of that scope. So for example, if you have a parameter name in a method that has the exact same name as one of your instance variables, and you use that name inside the method, you're referring to the parameter, not to the instance variable. So now let's take a look at a scope example. Figure 6.11 scope.java is going to demonstrate several scopes to us, and then separately we've got the scope test.java, which simply creates an object of our scope class and calls the object's begin method, which is going to control what we want to do for testing scopes in this example. So what I'd like to do is kind of go through the code and follow the execution of the code as we go. And for that purpose, I'm going to actually use the debugger inside of NetBeans. And the way that you're actually able to walk your way one step at a time through the code is by executing in debug mode and making sure that you've set up a breakpoint where the program will stop executing so that you can then decide how to proceed. So I'm going to do that here at line 13 in the begin method, and the way you do that in NetBeans is you just click in this gray bar at the left and it highlights the line that represents the breakpoint. Here we're saying that before this line executes, the program's going to stop and wait for me to give it commands via the debugger capabilities of NetBeans. And as you'll see, we're going to get a new area down here in the bottom right corner where it shows us what the local variable values are in each scope as we proceed through the program's execution. Now, before I start running, first let's talk about the instance variable x that we're declaring here at line 7. We have an instance variable of type int. It's private to the class. Its name is x and it has the initial value 1. And what we're going to show you is that when we declare a local variable with this same exact name, we're going to hide this instance variable during the scope in which the local variable is declared. So let's go ahead and run this, and we're going to do so using the debug main project feature inside of NetBeans. And as soon as I do that, it first goes and compiles the program. Then it displays these other windows down here. We have a watches window, a local variables window, and the call stack, which shows you the function call stack at this time. The local variables window is the one that I want to focus on for now. Now, at this point, the green line indicates the line of code that's about to execute, so we have not as yet declared the local variable x with the value 5, but you do see that there is a variable shown here called this. This is actually a reference to the current object that we're manipulating. We're going to learn more about the keyword this in a subsequent lesson in this video course. And this, because it refers to the current object, if you expand with the plus sign there, you see the instance variable x of type int with the value 1, which is the only variable that currently exists in this program. We haven't created additional variables within the scope object, and we haven't created any local variables yet. But we are now about to execute this one statement, and in the toolbar it has some icons that help you determine what you want to do for the debugger. This first one here is the step over, which says that you want to simply execute the statement that's highlighted in green. This next one is the step into command, and it is going to allow you to step into a method to see the internal workings of that method as it executes. And this is the step out command, which if you're inside of a method says finish executing the entire method and then go back to the calling method. Now for our purposes, we're pretty much going to use the step over and step into commands. Since we're not looking at a function call here at line 13, I'm going to use the step over command, or I can press my F8 key. And when I click it, it shows me that this line is still the breakpoint line. We're now looking at this printf statement as the next line to execute. And notice there's a new local variable now called x as well with the value 5. So you can see that there's really two different x's that are currently in memory in this application. However, this local variable x is now hiding or shadowing the instance variable x. So when I go to line 15 here and I print out the value of x, what we're going to see here is the value 5 being displayed. So I'm going to step over that line to execute the print. And if we take a look here in the output window, you can see that the local x in method begin is the value 5, not the value 1. So there's proof that the local variable is hiding the global variable. All right, so now we have a couple of other methods that we're going to take a look at. Use local variable and use field. And where the use local variable function is going to declare its own variable x. Use field is going to go back to the instance variable x and use it. So let's take a look at this. We're now about to execute the use local variable method, and I'm going to use the step into command to jump down to the use local variable method. So now we're down at line 28, getting ready to declare the local variable x and assign it 25. Let me just scroll up a little bit here. So now, if I do my step over command, we can see that we have another variable x whose value is 25. By the way, notice that the x with the value 5 from the begin method is no longer displayed in here. That's because it's not currently in scope. When you're inside the body of a given method and executing that method, that method's local variables are in scope at that point. So now we have this integer x local variable, and we're about to print out the value of that local variable. So I'm going to do a step over once again, and now we can see local x on entering method use variable is 25. We're then going to modify the value of x, and by the way, watch down here the value change as we do that. You can see that its new value is 26 because we incremented it by 1, and now we're once again going to print that value. And you can see that as we're about to exit this method, the value is 26. Now, as I leave this method and continue back to the caller, then the local variable x from the caller reappears down here in the local variables window, but the local variable x that we had defined in use local variable is now out of scope. It no longer exists in memory in this case either, because the function call has returned. So now we're about to execute the use field method. So I'm going to step into that method. And as you can see here, we're not declaring any local variables in the use field method. So when we go to output the value of the variable x in this printf statement, first it looks to see if there's a parameter or local variable in use field that is named x. And when it sees that there is not, it goes to the instance variables or fields of the class looking for a variable named x, and that's the one that it's going to output here. So to prove that, we'll do another step over, and you can see that the field x on entering method useField is 1, and you can confirm that down here in the local variables window. Now we're going to change the value of the field, and you can see that its new value is 10. And we're going to step over the next printf again, and you can see that as we're about to leave this method, the value of useField is 10, and now we return back to the caller, the method begin. Now notice that the variable x, the instance variable, still has its value of 10 because instance variables maintain their state during the lifetime of the object in which they are defined. So now we're going to call useLocalVariable again, and we'll step into that method. And scrolling down now, once again we're about to create a local variable called x with the value 25. So we step over that line, and now we see another local variable x with the value 25. And it is currently going to hide the instance variable for the rest of this method's body. So I step over the printf, and we see the x local variable with the value 25. I add 1 to it, and you can see that the value is now 26. And I print it again, and you can see that the value 26 is being printed as we're about to leave the method. And now I return back to my caller, the begin method. And finally, I'm going to call useField one more time. And now, as we enter the method, it uses the new value of the field. So as I step over this printf, you can see that it prints the value 10 because, again, the instance variable maintains that value as long as the object stays in memory. So now I'm going to modify it again, and you can see that the value of x is now 100, and we'll print it one more time. You can see that it prints out 100, and then we return back to the caller. And finally, the last statement we're going to execute before returning to main in this program is to print out the value of x in the method begin, which is this one back here at line 13. And when we execute that green line, you can see that we once again printed out the local variable with the value 5. As we return to main, we're at the end of main, and then when we run again, we've now completed the execution of this program. So in viewing the scope.java class definition, we were able to show you that we had an instance variable x, a begin method with its own local variable x, and then we also had a useLocalVariable method with its own local variable x. In the case of this method, useLocalVariable, and this method begin, while we were executing in the scope of each method, the curly braces that define the body, we could only see the local variable that was defined in that method. But as you were able to see when we went to the method useField, which did not define a local variable x, it was able to refer to the x variable and use the instance variable for us.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.